All right, we're going to get started now. Hopefully I can keep you awake after eating lunch. We're going to talk a little bit today about stack refactoring, refactoring our applications. But first of all, my name is Aaron Heckman. I'm an engineer at Tengen, the company that makes MongoDB. And I spend most of my time working on tools and support for the Node.js community in general. Particularly, I spend much of my day maintaining the Mongoose project, which is an ODM for MongoDB in Node.js. If we have time at the end, we'll look at some examples of that. But if you're interested in it, go check it out. So back to the topic for today. So we want to refactor our stack, and so we're going to look at some examples, what this means. It's more of a high-level talk here. We're not going to look at a lot of code, but what do I mean by refactoring our applications? What do I mean by refactoring our data model? And then hopefully look at some examples of both. So it's story time now. Starting with the three, because there's essentially three parts of the stack that I'm going to talk about. We have our clients, we have our application servers, and our database. So going back in time a little bit, around 2004, Gmail was released, and this was sort of, we kind of know the story, but I kind of want to recap. It's important. Gmail came out, and they were doing amazing things on the front end that hadn't really been done or done well before. And they were doing things like when it was really cool to talk about Ajax, they were kind of the first ones that were really kind of blew the doors off that. And this kind of exploded into the whole Web 2.0, that awesome buzzword that everyone loves. Everyone wanted rounded corners. It was the coolest thing ever. And so there's this big revolution going on about building richer and richer client-side applications. And these were traditionally, restricted to browsers, desktops, laptops, things like that. The mobile thing really hadn't happened yet. But it's continued on to this day, and now we're into the mobile. Everybody's got a phone. Everyone's got an amazing computer in their pocket. You're probably using it now. And these are also geo-aware devices. We've got our clients. They're writing richer and richer front ends. More and more JavaScript is being written in them. And the model, JavaScript has its own objects, right? It's got its own way of representing data. And another neat thing about this is that it's easily serializable, and we've sort of embraced this as a community. JSON is sort of the standard for just passing, data around, and it's a really great way to represent data, and it's natural JavaScript. So, sort of a use case here. We've got a client, and it could be a phone or whatever. It doesn't really matter at this point. But traditionally, we're sending a request off to an application somewhere, and the request could be, we could be sending JSON, or we could submit a form, or whatever. We're asking a question or submitting some data. And these have traditionally been written in something like PHP, Java, C++, Python, whatever your favorite language is. Fill in the blank. What we're doing at this point is we're submitting some data, and this other language besides JavaScript has to take this JavaScript representation of an object and turn it into something that is natural for the language in question. So there's a little bit of a translation layer overhead there. And then, if a database is involved, like any traditional application is these days, it then needs to convert that, based on the business logic with the objects. That's a tongue twister. It then needs to convert that into something like SQL, or maybe it's an insert, or it's just a query, or whatever. So traditionally, our databases have been relational, and we have yet another way to represent our data, which then is returned. We have some rows. Now we have a new representation of a data. So we've got JSON, we've got JavaScript objects in the front end, we've got application logic in the middle with its own classes, and we've got some rows and tables representing the same data in the database. And so you have this cycle. You have to go front and back, and usually, it's JavaScript that's driving this stuff. And so, let's look at refactoring our stack, because this seems pretty much wasteful, in my opinion. So if we're going to refactor our stack, what are we going to do? We're kind of stuck with JavaScript, really. There are some alternatives on mobile devices, right? If you're an iOS developer or Android, and you have some other options. But the common denominator, whether it's browsers or mobile devices, it's JavaScript. JavaScript is everywhere. That's why we have a conference today. So we're going to say that that's a given, and we're going to move forward. And the next, in my opinion, if we want to refactor our stack, it really makes a lot of sense to take a good look at Node.js. If you haven't looked at Node before, I would highly recommend just playing around with it, getting familiar with it, understanding its concepts and why it's making why it's creating so much buzz. And let's actually just look at a little hands-on example. Wow, that's not even on the screen. Cool. Okay. So what we're going to do is just have a little demo. This is the hello world of Node.js. Get a little better idea of what we're doing here. All right, so let's see. We're going to create an HTTP server. Whoops. Equals. Let's just do this. Okay. So what we want to do here is we want to create a web server with JavaScript. On the server side, we're going to use Node.js to do this. Again, this is very intro level here, so if you're bored, sorry. But so this is essentially the hello world of a Node.js application. And so there's this REQ is a request object, RES is a response object. The function here that we're passing into create server is a listener on every request event that occurs. So what we're going to do here is on every request, respond just with some plain text. Let's see, text plain, set a header so browsers know what to do. And we'll give it a little message. Okay, so at this point we have a server, but it's not running yet. And so your server gets started by calling the listen method. We pass a port, and we'll log a message running on localhost 8088. Okay, so we'll run this. Awesome. So far, this is blowing minds. All right, here we go. All right, it's a JavaScript web server. I think that's pretty awesome. When I first kind of discovered this stuff, end of 2009, early 2010, I have to be honest with you, I haven't looked back. This was earth-shattering for me. I had spent a number of years as a web app developer in general, and various different backend languages. But again, the common denominator has always been JavaScript. Building richer and richer front ends with more and more logic, having a single language to talk both client and server, representing my data the same way was just liberating for my mind, personally. So that's a real quick intro to Node.js. So that's 2. We're down from 3 to 2. Anyway, we're going to continue our refactor, and we've got one thing left that isn't like the others. Which one of these doesn't belong? And the dirty sock is SQL. Now, I'm not bashing a relational database in any shape or form. Absolutely, many, many, many use cases. It's proven technology. 30 years of research. It's awesome, right? But if we want to refactor our stack and do things in a more natural JavaScript-y sort of way. When I got into Node, to take a step back in time again, early 2010, I had my own startup. I thought, it'd be really cool. I'm going to simplify. I'm just going to use JavaScript everywhere I can. And for my prototype, I went with Node on the back end, and I was like, okay, this might just be throwaway technology. It might be really crappy. I don't know. This is brand new to me. So I just used this in-memory key-val JSON store to store my data. It worked. It was fast. It was stupid because you just shut down your server and your data's gone. It was really, really awful. But as a prototype, it was great. The bottom line here is, though, that the way I was working with my data, it was liberating, right? Because I already had a rich client. It was, I was passing JSON back to my server. JSON.parse that string into an actual, the same representation on my application, and then I was storing that same representation of my data in the database. So I was really, I really wanted, ideally, something more rich than a key-val store that stored JSON, but I really liked a lot of the capabilities that an SQL, would give me, a relational database would give me, like MySQL or whatever. So after a little bit of some searching around, I found MongoDB, and MongoDB is a little bit different. It's a document-oriented database, right? It's going to allow me to put objects in, just plain old, everyday JavaScript objects, and store them in the database. And so the easiest way to kind of get your head around this mentality is by comparing it, again, to a relational model. And so let's pretend for a moment that we had an app that we're going to build a new platform for stores to sell their own products on. So they want to define a few common things about a product. The product is going to have a unique ID. It's going to have a name, when the product was created, and the other three business requirements. The second one would be associating any amount of key value pairs, like to this product. And this is one way to do it. There's a lot of ways to do this. But traditionally, you have another table, and you join them together, and everything is wonderful. The thing is, again, to note here is that when you're submitting a query and you're doing a join on rows, it's a different representation of your data. There's some assembly required to then turn these rows back into actual objects that you're going to be using in your application layer. So bottom line is the app model. The way you're representing your data in your app is not the same as you're storing it in the database. It's another mental hurdle to jump through. So back to MongoDB, how would this be different? So how can we solve the same use case in Mongo? So it being dynamic, it being document-oriented with dynamic schemas. And let's look, we'll just jump into the shell. So what we're going to do here is that big enough, first of all? Bigger? All right, okay. Just tell me if that's awful, and I'll make it bigger. So we're going to just start the Mongo Shell, and we're going to connect to a JS.everywhere database that doesn't exist yet. So we're in this little environment here. And so there's this global DB object in this Mongo Shell. And let's do this. So we're document-oriented. We want to save a document. Everything, we're all about JavaScript today. So I'm just going to create a little object literal here in JavaScript. And I have 10 fingers. So here we go. So we just stored a document, and we can read the document back out. And this is what it looks like. Pretty much just as we stored it. The only addition is an underscore ID, which Mongo gives every single document. It's a unique identifier. The special type for unique identifiers in Mongo is the object ID. Otherwise, it's untouched. So what you can notice here is that the name is a string, fingers is a number. It's storing also, it's representing the types. And it's not just Java, it's not JSON, it's not stored as JSON in the database. It's something called BSON, which is a binary representation of a JavaScript object. And so it's retaining all of our rich types. You can query on these types later. And yeah, so also the second point I had on there were that these are dynamic schemas. This is just any object, any shape you want. The database is not going to tell you what to do with your data. So if I want to, create, let's see, we're going to insert another document. This is going to be Snoopy. He's a cartoon, so I'm pretty sure he's got 8 fingers. 6 or 8, I guess. Oh, and let's see, since the database doesn't care, we can put whatever we want in here. I think Snoopy likes dog food. Oh, we're running out of space. Okay. And he likes, we're out. Yeah, let's just do that. so I don't run off the screen here. So db.users.find. There we go. 2 documents. Start as is. Snoopy's got 8 fingers, an array. It's cool. You know, Mongo loves JSON objects. So whatever you want to put in a JSON object and throw at Mongo, Mongo's going to be cool with it, including binary data. So if you're working in a Node.js environment, you know, the buffer is a way to represent binary data in Node. You can just, using the driver, to store buffers. Like the driver will take care of it, store them as binary, and pull them back out and give you buffers back. So very, very handy. OK, back to what else here? Oh, OK. Rich Query API. All right, so I was looking for a few things when I discovered Mongo a few years ago. And one was, OK, I wanted this exact representation of my data. Since I was I decided I'm going to just do a JavaScript stack. But storing documents is one thing, but being able to query on them is another, right? We can't just use SQL. It's totally different. And so Mongo has its own query API here. And so we can explore that a little bit. So, OK, here, very obvious, very simple. I'm defining a matcher object. So any document that has a name matching Aaron is going to be returned here. And it's not just exact matches. You can pass JavaScript regular expressions. So anything that starts with that, it's still cool. It's still cool. So taking this a little further, regular expressions are OK. MongoDB does range queries. So we can look at, let's look at fingers. Let's query fingers, plural. So anybody with more than 8 fingers will be returned. Again, that's me. Less than is also allowed. Whoops. If I could, type 2 letters in the correct order. OK, less than 8, that's nobody. Less than 10, well, less than 10. There we go. Now we get Snoopy. So it supports range queries, lots of different types. You can query directly on the type. You can look for, hey, I need people with actually, with a number stored for fingers. Because since the database doesn't care, and it's not going to validate data that you're putting in there, you might accidentally store a string for fingers, for example. I mean, there's not going to be any validation in the database for this stuff. And so just kind of take a little example. Let's just keep this a little simple. So we're going to update now Snoopy. And we're going to set fingers to the string 5, OK? So let's just find everything. All right, so now we have fingers set to a string of 5. And if I look up, just to show you that types matter, nothing is found because I'm looking for the number 5. I'm not looking for the string 5. Okay, so this is just important to note. Types matter in querying, but Mongo is not going to tell you what to do. You're cool to do whatever you want with your data. So what this is really essentially doing is taking the power out of the database and the DBAs there and moving that control into the application layer, which is, in my mind, a better place for that to live. Because at the end of the day, my users, despite what product I'm creating, in any use case, the users are going to use my product a little differently than I thought when I went out and I had my idea and building this thing, and then my users went that direction with my product. And I need to be able to react. And by making this, not enforcing these rules at the database layer and letting my application control that, I think it's a good thing. It's been a good experience for me. All right, more of a natural fit. Atomic operators, we looked at that a little bit. I'm going to cover actually both of these two here. So atomic operators. So this is how you would update a document, right? I use this $set on the bottom of the screen, if you can see it. And so what there's more than just set. Let's see. There's a lot of operators for manipulating arrays and other things. So we're going to update Snoopy again. And this time we're going to say, oh, we're not going to, that doesn't make any sense. We're going to push, we're going to update, actually we're going to update Aaron. This is a little bit better of a demonstration here. So Aaron didn't have any likes, if you recall. Only Snoopy had likes. So we want to add some likes to me, and I like peanut butter. Peanut butter tastes good. Okay. Find them all. All right, so now I have an array. If you notice, it did more than, it did a couple things here. I used the push operator. Mongo found the document that matched a name on Aaron. It checked to see if I had an array in the likes property. And since that didn't exist already, it creates the array and then pushes the value onto it, all in one operation, one atomic operation. And so there's a lot of different atomic operators. If I keep pushing peanut butter, you're going to see that now it's in there twice. And so there's a rich number of atomic operators. And what this guy is doing is it says, oh, only add it if it doesn't already exist. So yeah, add to set is what will do that for you. It's similar to push, but it will create the array if it doesn't exist. Anyway, the point is that these atomic operators, there's a lot of them for manipulating your document. And the way these work is kind of essential to using MongoDB. MongoDB does not have any transactions, okay? No transactions. It's gone. So that freaked me out. And what really kind of saves the day, not completely, but on a document level, these atomic operators basically are all or nothing sort of operations. If they don't all work, go through okay, then none of them are going to go through okay. So it's sort of a document level commit. Yes?
So in this example, like peanut butter.
Yes.
They are the same.
Right.
It will only be stored once. Because they are both the same.
No, I don't. It's not that smart. I don't think the optimization is there. So I'm not a core engineer, but I'm 99% confident that that's actually duplicated the way it's stored. Yeah, no, I'm 100% on that because the way it's stored, the way BSON it works, it's stored, it's duplicated. And there aren't any optimizations, although there's a lot of talk about that, and I think we have some tickets open to maybe optimize a lot of things like keys and things like that. So, and then the last thing I want to just mention about this model here is that's I'll get to you in 1 second. The last thing I want to mention here is that so we can perform ad hoc queries, but they don't need to be slow. MongoDB, even though it's a non-relational database, it still supports secondary indexing. And so, like if we're querying on name a lot here, so I could create an index on just name, and then you can use compound indexes as well. So here's a compound index. And you can go further. It's got a lot of options. So if you want a unique index, and there's a lot of other stuff too. Mongo supports all that stuff. So anyway, that keeps. I think that's pretty neat because we have JavaScript rich objects. We want to be able to we can query them any number of ways, and we still keep those queries fast. And oh yeah, so I was in a JavaScript shell. It's yet another way MongoDB and JavaScript really just make a lot of sense together. In my experience, it's been great. So at this point, we've refactored our stack. We have one language to rule them all. That is JavaScript. And let's see. I think we have, 5 minutes or something. So we can do one of two things. Either we can answer some more questions, or we can start goofing around with something like Mongoose or whatever with a node in a node app. Or what do you guys want to do? Do you have questions? Yell something out. What do you want to see? Okay. I think you were first.
Okay. So if you want to update the name and find with the name itself, MongoDB.
So I'm going to go back to the shell. If I want to update the name,
Finding with the name.
so I'm going to change my name. What does that look like? That's the question? Okay, so set name to something else. Just double there. So it's not just a single level, though. Like I guess let's find one document that has likes of dog food. So what you're noticing here is that it will look in arrays of documents as well. And they're easy to query against. You just pass a single value, and it's smart enough to go, oh, this is an array. I better check all the values here. Yeah?
How do I look up my ID?
ID? So you would just pass this object ID, right? I'm just going to copy this guy. And then it's the same way anything else, right? So name is the key, or excuse me, ID is the key. I'm just going to paste the object ID.
So I can ask for all of the ID in that document.
You can ask for all of the ID in the document?
Yeah, so like instead of asking for name, I want to ask all of the ID that are on the document. Basically,
List all IDs.
Oh, for the whole collection or whatever, right? Yeah. Okay, let's do, yeah, that's a good question. Let's say we only want to return the IDs. So what that ends up looking like is we'll just grab everything. And so what you see here is the second argument is a field selection syntax. It goes deeper than one level if you want to using this dot notation. We can look at that, or we can skip it and you can look it up later. But what you end up getting back here is, although it's not displayed clearly, this is an array of documents. So like in the Node.js world, you run this query, you're going to get an array back. And you have to iterate these then to parse out the object IDs themselves. You can just do like a map or whatever. So you're still getting a document back with just one property. You won't just get the value. I guess maybe there might be another way. We could probably do it distinct, but yeah, that might work too. Anyway, yes?
The regex object only works for define.
No, no. Well, so it's, no. You can store a regex if you wanted to. You can use them. So there's more than just find, right? We looked at find. We looked at update.
Update also.
Update will work. Count. You know, it's a matcher. So like anywhere you're putting a matcher, it's going to work. There's a trick, though, something to really consider if you're using regular expressions. If you're not using a prefixed regular expression, well, why am I even going backwards? So this guy right here, it's not a good thing to do on a database with a lot of records. That's very busy. This is, indexing, it's not going to pick up an index because it's, but if you do prefix the thing, like, where am I? Here we go. Then if there's an index on it, it's going to be able to use it.
So you have the mercy of the regex engine.
Yeah. I don't really know how that is implemented in the other databases, but I imagine that's an awful thing to do on a big database in like a relational world as well. Yes?
For the regular expression, it's doing a full table scan, right? There's no index.
In this case, if I created an index on name and I have a prefix, so it's starting, it's going to use the index. But full table scan if you're not. Even if you can look at this at home. You can find out what the database is doing by just tacking on explain at the bottom of your query, and wow, too big for this screen, but you're going to see here, since I created this compound index, it's using the B tree cursor, which is that means it's using the index. Otherwise, it would just say plain cursor. I don't remember what it's called. Basic cursor was what it would say. Yeah, right here.
So Mongo is not going to be used for something like an online store. It's mainly for flat data.
I'm not going to say no to that. I mean, a lot of people do use that. You just have to think about your data differently. And so I don't want to we have 1 minute to go. I don't want to like underrate, let's see, objects. Let's just say database.objects.insert. It encourages richer documents. Since you can store any structured data you want, you might have, the document's got a name, and then it might have stuff. And stuff could be an array of more objects. Key, val, whatever, right? And you can query on these guys. So if you're, whatever, that's invalid syntax, but it doesn't matter. The thing is that these documents are more rich. You can store more data to represent your actual object in your application.
Okay, so there's just kind of duplication, kind of
Yeah, there'll be duplication. That's actually not that uncommon. But there are trade-offs, right? It's a NoSQL database. It's a non-relational database. You can simulate joins, but at the application level. But these are similar. This is the same kind of problems you could run into with almost any relational database. I wish we had transactions. We don't, but they're hard to scale. I mean, the Mongo has been designed. I'm out of time, so I'm just going to wrap it up. But Mongo has been designed from day one to be easier to scale horizontally. The guys who created this came from DoubleClick, so they were used to dealing with ridiculous amount of data. And transactions were one of the things they decided that's not easy to scale. We're going to dump that. Now, I would personally love to opt into a slow version, but it doesn't. I mean, right now there's tickets open for it. I don't know if that will ever happen, but think about your data differently. Think about richer objects, and then embrace the atomic operators. And you'll get a lot farther than you think. But it is a drastic change if you're not used to thinking about it that way. It's not this isn't a perfect solution for every problem out there. Absolutely not. No way. But it's a really fun way to work, and I enjoy it. Anyway, if you have any more questions for me, catch me afterward, around here, wherever. Thank you.